Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Math grade 6. We are in chapter 11, lesson 4. Today we want to learn what the meaning of mean absolute deviation and how to solve the mean absolute deviation. Before we will start in our lesson, I want to go to the Alif program. This is the dashboard of Alif program. And this is our lesson today. This is our lesson, This is our lesson today. Mean absolute deviation. I want to, from all girls, when you finish your schedule today, to go to your account before 4 p.m. and start to solve this lesson, please. Go inside this lesson. Go to the big idea. Please, before you start your solving, show all video.
The mean absolute deviation is a measure you can calculate to determine how far, on average, each data point is from the mean. The following dot plot summarizes the ages of 3 students. The mean is 13. We can describe the spread of the data by finding the mean absolute deviation, or MAD. The smaller the MAD, the less spread out the values are. First, we find the absolute deviation from the mean of each value. The absolute value of 11 minus 13 equals 2. The absolute value of 17 minus 13 equals 4. The mean of the absolute deviations can be found by adding them and dividing by 3 data points. 2 plus 2 plus 4 equals 8. 8 divided by 3 gives us our MAD of 2 2/3. Today, you will use the mean absolute deviation to describe a set of data. Saeed and Yasir both went fishing 4 days this week. The dot plots summarize the number of fish caught by each boy. The mean number of fish caught is 5 for both of them. We can describe the spread of the values by calculating the mean absolute deviation, or MAD. First, we find the absolute deviation of each value, or how far is each value from the mean. 4 is 1 away. The 5s are the mean, so the distance is 0. 6 is 1 away. On the right, 1 is 4 away from 5. 3 is 2 away. 7 is 2 away. And 9 is 4 away from 5. We can also find these numbers by taking the absolute value of the value minus the mean. For instance, the absolute value of 3 minus the mean of 5 equals 2. Great! Now, to find the MAD, we find the mean of these values. We add the deviations together and divide by the number of data points. The MAD of Saeed's data is 1/2. The MAD of Yasir is 3. Remember, the smaller the MAD, the closer the data points. The larger the MAD, the more the data points are spread out. Good. I think you're starting to get it.
Then you can go to the Explore, Apply, Relate, Last Look, then the last step, My Exit Ticket. But please be carefully when you try to solve to get a good mark. So I want from all girls, please, today, when you finish your schedule and before 4 p.m. clock, to go inside your account in Alif program and to solve our lesson here, okay? So today we want to learn how to find the mean absolute deviation. See with me now this video.
Hello boys and girls, this video lesson is on mean absolute deviation. We will also call that MAD. Okay, MAD stands for mean absolute deviation. So go ahead and get your notes ready to take notes along with this video and head your paper mean absolute deviation. Okay, the first thing I want you to write is MAD, and we're going to put the definition of what the mean absolute deviation is. And it is the average distance between each data value and the mean. It's what mean absolute deviation sounds like. The average, which is the mean. Okay, distance is the absolute value. Okay, it cannot be negative. And then deviation comes from finding the difference in each data value and the mean. Okay, so next put the steps to find MAD, which there are 3 steps. First, you're going to find the mean. Okay, you add up all your values and divide by how many values there are. Okay, and that's your mean. And then you find the distance between each value and the mean. Okay, and once you have all of your distances, you're going to find the average. So you'll add up all those distances and divide by how many there are. Okay, so first example we're going to look at down here is the mean is already given to you. And then we have these values along this number line. So we have 48, 52, 54, 55, and 56 is our mean, then 58, 59, 60, and 62. So the mean we already have is 56. Now we're going to find the distance from each of these values from the mean, and then find the average of those values. So the distance from 48 to 56, we can just count along the number line, 1, 2, 3, 4, 5, 6, 7, 8. And then 52 from 56 is 4 away, and 54 is 2 away, 55 is 1 away. Okay, then 56 we have, or right after 56 we have 58, which is 2 away from the mean, and then 59 is 3 away, 60 is 4 away, and then 62 is 6 away. So we should have the same amount of distance values as values along the number line. So let's make sure 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So good. We have not left any out. So now we need to find the sum of all of these, because that's what you do when you find the average, and then divide by 8, since there are 8 of them. So let's add up here. We have 8 and 4 make 12. 2 is 14, 15, 16, 17, and this makes 20, 24, and then 30. And then we are going to divide by 8. And when you do 30 divided by 8, you get 3.75, 3 and 75 hundredths. Okay, so the average distance of these values from 56 is close to 4, but not quite 4. About 3, and it is 3 3/4. And you should look and see, does that make sense? So 3 3/4 would be 1, 2, 3, about here. Does that seem close to the middle? 1, 2, 3. Does that seem close to the middle? So make sure that your value does not have something that would be way outside your lower and upper extreme or too close to your median or your mean. Okay? And that is how you find the MAD of a set of data. So let's do one more. Okay, here we're going to have to find the mean ourselves. So step 1 of this set of data, there's speeds, 35, 38, 41, 35, 36, and 55. So first we have to find the mean, and when you find the mean, you're going to add them all up. Okay, and when you add all of these up, you get 240. And then divide to find the mean, 1, 2, 3, 4, 5, 6, by how many there are, and there are 6. So this equals 40. So the mean, or the average, is 40. Okay, so now you can make a table, or you could do a number line like on the first example of finding the distance from each one. So I'm going to show you how to do it in a table. So you're finding the distance from each one of them, the distance that each one of these values is from 40. So I'm going to list these values: 35, 38, 41, 35, 36, and I need more room here, 55. Okay? So here's the value, and then we're going to find the distance. Okay, how far is 35 from 40? Pretty easy, right? That one's 5. 38 is 2 away. 41, just one more. 35 is 5 away. 36 is 4. And 55 is 15 away. Okay, now add up all your values. So you have 15, 16, 17, 18, 19, 24, 25, and that makes 32. So when you add them all up, you get 32. And then remember, you divide by how many values there are. And there should be the same amount of distances as there are values to begin with. And there are 6, 1, 2, 3, 4, 5, 6. So we're going to divide by 6. And this equals 5 and 3 repeating. And so you should leave your answer for the MAD as what the directions tell you. Sometimes they'll say round to the nearest tenth, which you would just put 5.3. Round to the nearest hundredth would be 5.33. Or you could write this as a fraction, which remember 3 repeating is 5 1/3. Okay, and that is how you find the MAD. All right, you have a good evening, and if you have any questions, bring them to class tomorrow, and we'll go over them first thing. Bye-bye.
So this is the meaning of absolute value. Today, we want to learn how to find the mean absolute deviation. When you want to solve to find the mean absolute deviation, you should to find the 3 steps. The first one, find the mean, find the mean. Then the second step, find the absolute value of the differences between each value in the data set and the mean. Then the last step, find the average of the absolute values of the differences between each value in the data set and the mean. I will repeat. When you want to find the mean absolute deviation, you must to find the 3 steps. The first one, find the mean, then find the absolute value of the differences between each value in the data set and the mean. Then the last step, find the average of the absolute values of the differences between each value in the data set and the mean. To know what the meaning of this step, watch with me this video.
In this video, we're going to talk about mean absolute deviation. We're going to start off with a definition, and then we'll look at the steps on how to find it. So the mean absolute deviation is a way to measure the variation within a data set. It's going to represent the average distance between each data point and the mean. There's 3 main steps that we're going to look at to find mean absolute deviation. We can abbreviate AD. The first thing that you're going to do is just find the mean. So we know from before that if you're going to find the mean, you're going to add up all of your data values, and then you're going to divide by the number of data values that you added up. So main operations, adding, and then division. The second step, once you have your mean, you're going to find the distance between each data value and your mean. The operation that you're going to be using for that is just subtraction. And then once you have found your new numbers, you're then going to find the mean again. So you're going to take all of the numbers from step 2, find the mean. So you're going to be doing the exact same thing that you did in step 1, which is adding and then dividing. You're just going to be using your new set of numbers. So we're going to work through an example where we find
two different mean absolute deviations, and then we're going to go ahead and compare those together. So we have a table that's representing the prices of the 5 most expensive and the 5 least expensive dishes on a menu. Again, mean absolute deviation is going to be the average distance between each data value and the mean. Let's start with the 5 most expensive dishes. So we saw from before that the very first thing that we're going to do is find the mean. And for this one, we have 5 numbers that we're going to add up. So 28 plus 30 plus 28 plus 39 plus 25. And then after we add those up, we're going to divide by 5 since there are 5 data values. So when we add up all of the numbers in the numerator, that's going to come out to be 150. And then 150 divided by 5 is 30. So then our second thing that we're going to do is find all of our differences. So second, find the differences. And basically, we're just going to be subtracting this mean with all 5 of the numbers that are listed in the most expensive dishes. So we'll go ahead and start with 28. We always want to subtract to get a positive number. You're basically finding the absolute value of your distance. So we're going to do 30 minus 28, which is 2. Then we have 30 minus 30 to get 0. Next, you're going to do another 30 minus 28, which is 2. And then this time we'll put 30 on the bottom because we want a positive number. So 39 minus 30 is 9. And finally, 30 minus 25 is 5. Now, obviously, you probably don't need to actually write out those subtraction problems, but I just want to be really, really clear about where these numbers are coming from. Okay, and then for the third part, we're going to go ahead and find the mean of all the numbers in part 2. So we'll find another mean. So this time we'll use 5 numbers from part 2, 2 plus 0, plus 2, plus 9, plus 5, all divided by 5. So when you add up your numerator, you're going to get a total of 18. And 18 divided by 5 is 3 6/10. So the mean absolute deviation for the first set of numbers is 3 6/10. That means on average, each of these prices are about $3.60 away from the mean of 30. All right, now let's look at our 5 least expensive dishes. We're going to go through those same steps just with different numbers. So just like before, I'm going to go ahead and start off with finding the mean. So we can add up 7 plus 7 plus 10 plus 8 plus 12, and then whatever we get, divide that by 5. So this time the numerator adds up to 44. And 44 divided by 5 is 8 8/10. So $8.80 is the average price of all of those dishes. So then for step 2, we'll go ahead and find our differences again. We'll just subtract. So since I've got a decimal or a number in the tenths place, it's going to be especially important to be sure that I'm lining up my decimal points. So when I start with $8.80, I'm going to subtract 7, and again, line up your decimal point to be sure that you've got the right value. So that's going to be 1 8/10. We have another value of 7. So same thing for our second number. Then our third number, we're going to put 10 on top since it's larger and subtract 8.8 from that to get 1 2/10. Then we're going to subtract 8.8 minus 8 to get 8/10. And then finally 12 minus 8.8 to get 3 and 2/10. So important part on that is just making sure decimals are lined up. And then we're going to go ahead and find the mean of those numbers. So, all right, step 3 is another mean. And you don't necessarily need to label each one mean, difference, mean. But again, I just want you to be able to see exactly where all these numbers are coming from. Okay, so part 3, we're going to find the sum of the 5 numbers in step 2. So we'll add all of those up. And then whatever we get, we're going to divide by 5. So the sum of those numbers comes out to 8 and 8/10. And 8.8 divided by 5 is 1 and 76/100. So right here, this is going to be the mean absolute deviation for the least expensive dishes. That means that on average, the dishes are about $1.76 away from the average, which was $8.80. Okay, now we're going to go ahead and write a comparison about which one has more variation. So just remember that mean absolute deviation shows you how much the numbers vary from each other. A higher mean absolute deviation means that there's more variance. A lower mean absolute deviation means there's less variance, so the numbers are grouped a little bit more closely. Okay, so for my comparison, remember the more expensive, so I'll do maybe more expensive, that was 3 and 6/10, and then the least expensive was 1 and 76/100. So we're going to go ahead and use those values to write a comparison between those two things. All right, so an example of what you could write for your comparison, I said the more expensive dishes have more variation within their prices. I know this because a mean absolute deviation of 3 and 6/10 is greater than a mean absolute deviation of 1 and 76/100. So that concludes mean absolute deviation notes. Remember 3 things you're going to do: find the mean, subtract to find all of your distances, and then find the mean of all of your new numbers. So none of this is super complicated math. It's just a matter of being really organized and taking your time and making sure that you don't make a mistake that will throw everything else off. And then once again, mean absolute deviation is just a way to measure how spread out the numbers are, and it's going to be your average distance between each data value and the mean. All right.
Okay, this is the meaning of this step, these steps. Now we have this example 1. The question here, find the mean absolute deviation for set of data. We want to find the mean absolute deviation. The data here inside the table here, this table, the number of daily visitors. We have here, as you see, we have 1, 2, 3, 4, 5, 6, 7 numbers. 112, 146, 108, 160, 197, 109. How to find the mean absolute deviation? We have 3 steps. We have 3 steps to find the mean absolute deviation. The first one, find the mean. Find the mean. Find the mean. How to find the mean? Add the all numbers inside the data here, then divide by the number of set of data. So I can write 112, 100 plus 146 plus 108 plus 160 plus 100 plus 97 plus 109 divided by how many groups we have here? 1, 2, 3, 4, 5, 6, 7. Divide by 7. Now, the sum of the all numbers up here will be 832. Will be 832 divided by 7. Divided by 7. The answer here, approximately, using the round, will be 120. Will be 120. This is the first step. We found the mean. We solved the mean. This is the first step. The second step, find the difference between each value inside the data here and the mean. Between or through the absolute value to keep the distance. How? Draw the absolute value. I want to remember you the absolute value, the two parallel columns like this. And the absolute value, keep the positive number as a positive number and change the negative number to the positive number, and we use the absolute value to keep the distance. So the first value 112 minus the mean throw the absolute value 112 minus 120 will be minus 8, negative number. Minus 8 throw the absolute value will be changed to the positive, will be 8. Then take the second value 146 minus 120 throw the absolute value. 146 minus 120 will be 26. Now take 108 minus 120 will be minus 12. Between absolute value will be what? Will be 12. Then take the value here 160 minus 120. 160 minus 120 will be 40. Then take 100 minus 120 will be minus 20. Between absolute value will be 20. Then take 97 minus 120 will be minus 23. Between absolute value will be what? Will be 23. The last value here 109 minus 120 will be minus 11. Between absolute value will be 11. This is the second step. The difference between each value inside the data and the mean. The third step and the last step, MAD. What's the meaning of MAD? M means the mean, A means absolute, D means deviation. How to find MAD? Find the average for these numbers. How to find the average? Add the all numbers here divided by the number of all numbers. So here we have 8 plus 26 plus 12 plus 40 plus 20 plus 23 plus 11. Divided by, I have here 1, 2, 3, 4, 5, 6, 7. Divided by 7. Now the sum of the number up will be 140 divided by 7. 140 divided by 7 will be here what? Will be 20. I will repeat how to find the mean absolute deviation in this table. In this table we have this data. We have 6 groups of numbers, 1, 2, 3, 4, 5, 6, 7, 7 groups of numbers. And we have this number 112, 146, 108, 160, 197, 109. The first step, we have 3 steps to find the mean absolute deviation. The first step, find the mean. How to find the mean? Add all numbers inside this data divided by the number of set of data. So I can write here 112 plus 146 plus 108 plus 160 plus 100 plus 97 plus 109 divided by 1, 2, 3, 4, 5, 6, 7 divided by 7. So the sum here, the sum up will be 832 divided by 7, approximately equal 120. This is the first step. The second step, take each value inside the data, inside the table here, then find the difference between this value and the mean. Between absolute value to keep the distance. So I can write here 112 minus 120 will be minus 8. Between absolute value will be 8. Then I can write here 146 minus 120 between absolute value will be 26. Then I can write here 108 minus 120 between absolute value will be minus 12. Between absolute value will be 12. Then I can write here 160 minus 120 will be 40. Then I can write here 100 minus 120 will be minus 20 between absolute value will be 20. Then I can write here 97 minus 120 will be minus 23 between absolute value will be 23. The last value here 109 minus 120 will be minus 11 between absolute value will be 11. This is the second step. The third step, find MAD. MAD. What's the meaning of MAD? MAD, the symbol of mean absolute deviation. Mean absolute deviation. How to find MAD? Find the average for all numbers here. The average, the same meaning of the mean. The same meaning of the mean. What I do? Take the all numbers and find the sum. 8 plus 26 plus 12 plus 40 plus 20 plus 23 plus 11. Then divide by the number of these numbers. 1, 2, 3, 4, 5, 6, 7. Divided by 7. The sum of the numbers up will be 140. Divided by 7 will be 20. The second example here. Find the mean absolute deviation for set of data. We have here this table, recorded speed meter per hour, and we have here 1, 2, 3, 4, 5, 6 group of speed, 35, 38, 41, 35, 36, 55. How to find the mean absolute deviation? We have 3 steps. The first one, find the mean. How to find the mean? Add the all numbers inside the data here, 35 plus 38 plus 41 plus 35 plus 36 plus 35 plus 55, divided by the numbers 1, 2, 3, 4, 5, 6. The sum up will be 240 divided by 6. 240 divided by 6 will be 40. This is the first step. The second step, find the difference between each value inside the data here and the mean between absolute value to keep the distance. So I can write 35 minus 40. 35 minus 40 will be minus 5. Between absolute value will be 5. Then 38 minus 40. 38 minus 40 will be minus 2. Between absolute value will be 2. Then 41 minus 40 will be 1. Then 35 minus 40 will be minus 5. Between absolute value will be 5. Then 36 minus 40 will be minus 4. Between absolute value will be 4. Then the last value, 55 minus 40 will be 15. This is the second step. The third step, MAD, mean absolute deviation. Find the average of all these numbers. So I can write 5 plus 2 plus 1 plus 5 plus 4 plus 15 divided by the numbers here 1, 2, 3, 4, 5, 6. Now the sum of the numbers up will be 32 over 6 will be 5.3333 to the infinity, or 5.3 per notation. So I can round here to the 5.4, to the 5.4, or to the 5, it's up to you, no problem. Yani it's approximately 5.4, 5.4. So I will repeat this example. We have here this table recorded speed meter per hour. We have 6 speeds here, 35, 38, 41, 35, 36, 55, and we want to find the mean absolute deviation. And very important to remember, when you want to find the mean absolute deviation, you should to find the 3 steps. The first one, find the mean, then find the difference between each value and the mean, then find MAD. How to find the mean? The mean means the sum of the number inside the data divided by the number of set of data. So I can write 35 plus 38 plus 41 plus 35 plus 36 plus 55 divided by 1, 2, 3, 4, 5, 6. Divided by 6. The sum up here will be 240 divided by 6 will be 40. Will be 40. The second step now, take the difference between each value and the mean. Throw or between absolute value. 35 minus 40 between absolute value will be 5. 38 minus 40 between absolute value will be 2. 41 minus 40 between absolute value will be 1. 35 minus 40 between absolute value will be 5. Then 36 minus 40 between absolute value will be 4. Then 55 minus 40 between absolute value will be 15. The third step, find MAD. What's the meaning of MAD? Mean absolute deviation. When you want to find MAD means find the average, find the mean of the numbers here, the answer of the difference between the each value and the mean. So I can write 5 plus 2 plus 1 plus 5 plus 4 plus 15 divided by 1, 2, 3, 4, 5, 6 divided by 6 numbers. The sum up will be 32 divided by 6. The answer will be 5.3 per notation. So I can round to the 5.4. Approximately equal 5.4. So this is our lesson today. We learned today how to find the mean absolute deviation. Now, who has a question now? Girls, who has a question?
No one.
It's clear for all?
Yes,
Right.
clear.
Great. What is the
Yes,
title of
yes.
our lesson today? What we learned today?
Mean absolute deviation.
Mean absolute deviation. Mean absolute deviation. We have 3 steps to find the mean absolute deviation. What is the steps? What is the steps?
Find the mean,
Great.
then find the distance,
Great.
then make plus. And
Then
divide
find
about
find
the
MAD
the total.
average. Find MAD the average. Excellent. Thank you. Now let us to take attendance now. 6G, today Wednesday. This is the third period. Aliazia. Where is Aliazia?
موجودة.
Great. Becca. Where is Becca? Absent? Okay. Rauda.
Yes.
Great. Sarah. Where is Sarah? Sarah. Absent? Okay. Selma. Absent. Okay. Aisha.
Yes, Mr.
Okay, great. Fatima.
Yes.
Great. Layan.
Yes.
Excellent, Layan. Excellent.
Bye, Mr.
Bye. So this is our lesson today. Thank you for your listening. Have a nice day and have a nice weekend.
Bye, Mr.
Next week. Bye. See you inshallah next week. Assalamu alaikum wa rahmatullahi wa barakatuh.